Welcome to today's episode of CCSD Earth Science. I will be your host once again, Mr. Miller. Today we are going to cover the topic of topographic maps. As you can see behind me, topographic maps are a two-dimensional model, paper model, of elevations of various points on the Earth's surface. Now, we're talking about things such as mountains, rivers, valleys. You can see almost anything where lakes are. Direction of water flow. We talked about that last time in our previous episode. Anyways, gradient. What we're going to cover on gradient is going to be the rate of change or the slope between two places on the Earth's surface. Now, the gradient is how steep or gentle a slope is. I didn't have quite enough room to write slope in there, but steep gradient, gradual gradient, and pretty much flat, okay? And so that's what this is something that you can calculate. Now, what we're going to do is using your reference table, your ESRT, you can get this equation right off there. Gradient equals a change in field value. That's what it says in your reference tables, is change in field value. Now, change in field value doesn't really mean much, but the field on a map is the elevation, okay? That's what we're worrying about, so it's going to be the change in elevation. That's why I wrote elevation really small right there in that space. Now, all of that divided by the distance that you travel between those 2 points. So it's a change in elevation divided by the distance between 2 points. Okay? Now, the closer those points are together, if the points are really close together, then they will have a small distance. And if the elevation changes a lot, it'll be a steep gradient. And if the elevation doesn't change that much between those 2 points, it'll be a gentle or not a steep gradient. All right. Now, for example, if you had 200 feet change in elevation, if the elevation changes 200 feet between 2 points, and those 2 points are 5 miles apart, okay, then that would be a gradient of 40 feet per mile. Feet right there, miles down here, gives you a unit of feet per mile. Now, that means that the elevation changes 40 feet for every 1 mile that you go. So if you were walking a mile, you could expect to change. Now, we don't know if this is up or down, okay? You would expect to change 40 feet, okay? This works very well to try and figure out the gradient of hills or a road even, things like that. Okay, moving on. Now, some of the features, I'll get out of the way here. Some of the map features that we will be talking about are depressions. These you'll see on some maps. I talked about this last time. Hopefully you still remember. If that value right there is 80, what's the value of that line right there on the depression? That is also going to be 80. Okay? Now then, if you had another depression line, which would be another contour line in there with the hatcher lines in there, then that would be going down. So you're coming up to 80. Out here would probably be 60 if there was another line. Okay? And you'd come up to 80. You'd go up a little bit, and then you'd go back down in. This is where the ground sinks in, such as a volcanic crater, the center of a volcano when you go down into the crater of the volcano. A sinkhole where the ground is typically flat, and just all of a sudden the ground gives way and kind of caves in. That's an example of where you'd see depressions. I did also talk about asteroid strikes. If they were in recent history, they typically would show up as a depression also on a map. There's other examples, but those are the most common ones that we'll ever see. Okay? Now, this right here, this is typically the way that it's drawn. You'll see this little arrow with an N next to it. Now, sometimes it might be off at an angle a little bit, and it might be showing it off in a different direction. That means that direction is north. Or if they put an E next to it, that was where east would be. Well, if this is north, you know that east would be off this direction, south, and west. Okay? Helps you figure out the directions on the map itself. And that we call a compass rose because the round compass with the arrows on it and all the directions, that's the real compass rose. But it shows direction on a map. Okay? Usually only north is labeled, as I put here, just like that. Okay? Now another thing is a scale. Now the scale is going to be written differently depending on the map that you're using. Okay, if you're trying to show a map of Carthage, it might not be a map quite that big of a scale. It would be 1 to 10,000 scale on a map. On this particular example, that is the scale, which 1 inch or other measurement, I mean, you could lay a pencil down on the map, and from one edge of the pencil to the other side of the pencil would be 10,000 pencils in real life between those 2 points. I like to just think of it, 1 inch on the map is 10,000 inches at that real location, or between those 2 locations. Okay? So, and like I said, like your Matchbox cars that some of you may have played with or have seen somebody play with, okay, those are typically somewhere in the ballpark of a 1 to 64th scale. If you measure 1 inch on that car, it's really 64 inches on the real car. And all the Matchboxes are a little bit different. The great big heavy trucks, they're about the same size as a car. Well, obviously they're a little bit bigger than a car, so they're going to be a little bit different scale. That might be 1 to 100. Okay, 1 inch on that might be 100 inches in real life. Okay, but that's what you're going to see. Some of the maps that we'll be using are 1 to 64,000 scale. Okay, so 1 inch on the map or 1 foot on the map is really that many feet in real life. All right, profiles. Profiles are the side view of the land. Okay, this right here is a profile of me. It's the side view, okay, of my face. Okay, so that's what we're going to try and show with this diagram here. Now this is the way that a map would look. Okay, you've got the 40-foot contour line. How do I know it's feet? Because it's written right down here. Okay, it says feet right there. So if that's 40, no hatcher lines, so this has to be going up. Okay, we're going up because it's coming in, circling in. So this is the peak of a hill or a mountain or whatever. But anyway, so this is not a very big mountain at this elevation here, I guess. So that's 40 feet. The value of that line should be 60 feet if it's a contour interval of 20. So that would be 60, and that would be 80. If you want to label that on your map, go ahead and do so right now, because you really should have that on there. Now, so if that's 40, 60, 80, the peak of this hill, can it be 100? No, it can't be. Because do you see another 100 line? If there's not another line, it can't be that next elevation. But let me ask you, would the peak of this hill be 80? No. If that's 60 and that's 80, the 80 line would go through the peak of the hill. Okay, where's the peak? I don't exactly know. I would guess that if it's getting up right here, it'd be somewhere in this ballpark here. But I don't know for sure. Okay? Now, what you need to do when we do these particular profiles is you have the map drawn like this. Now, if you guys copied this already, this isn't as accurate as it will be when we do this in class. But you will take a piece of scrap paper, and you will take the piece of scrap paper and line it up with your 2 points along the line, straight line distance. And if you see, I made a mark for A, I made a mark for B. And then I carefully made a mark where each line crosses my piece of paper. Okay? Now, once I made all those marks, I then went back, and this is where it would be really handy to label that one 60 and that one 80, so then I know, okay, that's my 60 right there. So I made that mark, and I label it 60. Label that one 80. Label that one 80, 60, and 40. Okay? Now, A, I had to guess at that. I don't know what it is, but I know it can't be 20. That's what I put down here. A and B are not on the 20-foot line, so you can't label them 20. So I said, oh, it's pretty close to the 40, so I don't know, 35. I thought it looked like it could be 35, so I just labeled it 35. B over here, I labeled that one 37. I didn't think 35. I think 35 would be probably a little farther out here. So I just called it 37, but I know it's not 40 and I know it's not 20. So somewhere in between there, I guess, could be accurate. Now, when you have these marks on the piece of paper, you then come over, and if you didn't have any of this drawn yet, and you just had those lines, blank graph paper, okay, has A right over here on this side with that mark, and B right over here on this side with that mark. So I double check, do my marks, yep, they line up perfectly, okay? And so I'm going to slide this up. keeping my paper straight with the edge of A. If the mark for A was over here, what I would end up doing is I would make a mark on the edge of my paper so that I'd be able to keep that straight all the way up. But anyways, if you keep A, since it's right there on that axis, okay, and I'll keep it lined right up, I'm going to slide this up until I get to about 35. Oh, I'm at 35, so I'm going to put my dot right there because that's the elevation of A. Now, I'm going to slide it up a little bit more. Can't forget, if you forget about it, you can come back and do this. Make sure A stays lined up on this side. And then over here I have B at 37, so I put my mark for B at 37. I have no line drawn at this point in time. And then, keeping A lined up with the axis here, now I came up to my 40 line. I'm going to put my dot right on that 40 line, right where it matches up on my paper. And same thing over here on this side, if you can see it. Okay, right there's that dot. Then you take the paper, keeping A lined up with the left-hand edge. You may want to come back and watch this video again when we start doing some of these profiles because this will be very helpful. And right there is A again, keeping it lined up. Now I'm at the 60 line. So right here, that far away from A, I now have an elevation of 60. That matches up with that point right there. So it's that far away from A. So now I'm at 60. Well, also over here I had a 60 also, so I'm going to make that dot right there. Then I'm going to bring it up even more, and I'm going to come up to the 80. Make my dot there, and make my dot there. So now I've got all my dots. Now if that green line was not drawn, okay, you just have your dots. Now what you do is you use a smooth line and connect your points. Okay, now I connect here, and I come up. I stop right there typically, and then I continue drawing it. And I don't know, you might be able to see that I did stop that line right there. Okay, and I draw it and connect it over here. Now, do I come up to 100 feet over here? No. So since I don't, I cannot touch that next line. I cannot touch that 100-foot line because I don't have a 100-foot value here. Okay, that's what a lot of people think. Oh, I'll just slide it up and just make my line go up a little bit higher, and I'll touch the 100, and then it'll come back down. No, that is incorrect because this does not go up to 100. Do I know that it goes up to 90? Do I know that it goes up to 85, 95? I don't know. As long as I make it go above 80, because the 80 is here, okay, and the 80 is here, it has to be above 80, but it can't quite be 100. And that's the big thing. I have to see, to give you credit, I have to see space between the 80 line, okay, and your line, and I also have to see space between the 100 line and your line. And that's why I went right about in the middle, because that's a pretty safe place to be. Okay? And then just round it off. Now, why did I make it look a little bit higher here? Well, just based on my map, I think that's what it looks like. It's coming up pretty steep, so it's probably going to come up steepest right about here, and then it's going to come down gently. Now, if this was a real mountain, okay, that would be a lot steeper climb. Okay? Huh, look at that. It's very steep. Now, understand that isn't as steep as it would look because we're not equal scale with elevation and distance down here on the bottom. But this exaggerates it and allows us to visualize it a little bit better than just looking at a map like this. Okay? So it makes an exaggerated scale here. But we do understand this is steeper on this side towards A and a lot more gentle slope over here on this side towards B. This would be the easier climb. Okay? If you're going with your grandparents or somebody like that, you might want to start out at B and climb up here, okay? If you were going yourself, or, I guess if this isn't that steep, but only if you were going yourself and you wanted a little more challenging climb, you could come up on this side, over by A, because it's definitely steep. Okay? Now, the other thing I wanted to tell you is do not mark another line that they do not touch. Don't put A or B on the 20. Okay, that's what a lot of people are like, oh, I got another mark on my paper, so they take their mark, oh, yep, 80, 60, 40, and that one's going to be 20. No, that's not on the 20. That's why you have to label it. I like to label it A and label that one B, so I understand. That's A and B. They may not be on the line. If they are on a particular contour line, label them that way, okay? Now, like I said before, I didn't label these, but I wanted you guys to be able to see that if it's a contour interval of 20, okay, that's going to go from 40 to 60 to 80. When you do this, it's great to make sure that you label these lines before you go ahead and do these. Okay? I think that should cover it for today's lesson. But that's a quick lesson on making profiles. The only thing I do want to add is be careful, because every once in a while you may not have A right here on this edge. It may be over here a little bit. And then that is when you make a mark right here on the edge of your paper. And yep, and that should cover it. All right. This is Mr. Miller, and join me again on our next episode of CCSD Earth Science.